Hello everybody, welcome to Python CodeMan. Kindly subscribe and hit the notification button to always get my updates. So before we get into more serious work with Python, let's try to first of all see what are the basic operations in Python. Okay, so if you are a beginner or trying to move from ground zero to the beginner level, intermediate and expert, this is for you. Okay, subscribe and hit the notification button to always get my updates. So let's get to see what are the basic operators in Python. The different types we have arithmetic operators, comparison relation operators, assignment operators, logical, bitwise, membership, and identity operators. Of course, you may find that there are several of them, but the most common ones are the first four or three that we can always work with every day. So let's try to look at what are arithmetic operators. So when we talk about arithmetic operators, we are trying to look at the most commonly used operators: the addition, subtraction, multiplication, division, finding the remainders, exponent, float division, and so on. Okay, so we'll see how we can apply or try to see how the examples of each of that as we move on. So the next one is the comparison operators, where we have to look at the two numbers and we know whether the two numbers are similar, and then we say either it's true or it's false. Okay, if the numbers are not equal, or a certain number is not equal to the other one, less or greater, less or equal to, and so on. Okay, so this is what we are going to look at in the definition in the examples, and we see how we can apply that in our daily computations. So lastly, we have some assignment operators. For example, we can say x equals 2. That is an assignment whereby x is assigned to 2, and we can, in Python, we can always change that as we move on, and then Python will simply update. And we have some shortcuts here, as we can see. The plus equals, and that is defined by, let's say we have C, and C is plus equals to A. That simply means that C is equal to the C plus A, whereby this C is the previously defined C. So in such a case, that means we need to first of all define our C initially, or initialize, or based on some initial conditions. Okay, that same shortcut applies to both minus, multiplication, division, and so on. Okay, let's get to some examples and we see how we can apply that. So let's begin with addition. Okay, so we'll begin by assigning what you have seen as an operator. We'll say x equals 2, and then we assign y to be equal to 3. And so if we want to test addition, we can say x plus y, and that should give us 5, which we can see. Okay, and then we can do that for several of them. So I'll just straight away go to subtraction, and we have x minus y equals 2 minus 1. But let's say we wanted to assign the sum or the subtraction to another variable, then we can say z equals x plus y, and that will not return anything because it's now just a variable z assigned to the sum. So it's only until we call z, and then that will give us 5. The same applies to subtraction. Let's look at multiplication. Okay, for multiplication, we do the same thing using the star. So we can say x star y equals 6. Okay, the same would apply if we say x times y, and that will give us z. So if you call back z, it will give you 6. Let's try to look at the division. So x divided by y, that will give us 0.66. okay, and that's the division. If we wanted to say maybe to look at a remainder, we would then use the modulo. But before we go to that, let's look at the power or the exponent. Let's look at x power using double star. That will give us 8. Okay, let's say that one, it will give us 1. Okay, I'm not sure where it is getting 1, but you can see that if you use this symbol, it will not work for the power. It's only when you use double star and then get the exponent 2 power 3. Of course, there are some other methods that depending on the version of Python that can compute the power. So going on with the modulus, which we defined as or modulo, which gives us the remainder. If I write y, which is a 3, modulo, with a percentage, modulo x, that should give us the remainder. So 3, in other words, divided by x, the remainder is 1. Okay, let's test. If we have 2 modulo of 2, the remainder we know is 0, so that will give us 0. And let's test with some numbers. 5 divided by 2 or by 3, we know the remainder is 2, so that should give us 2. Okay, so this percentage or the modulo is very important, especially if you're looking for numbers that are even and those that are odd. Let's take a case when you have a list, a list of numbers, let's say 2, 3, 4, 5, and then 7. Okay, we know here the even numbers we have 2, 4, right? The rest are odd numbers. So let's try to use a for loop for I, where I is any number in list, for I in L. Okay, so now this is a membership operator whereby we are looking at I being in this list. Okay, so we can set a condition for the even. If I, if I is divided by 2 and the remainder, so I'm using this operator equals, must be equal to 0, then that means that I is an even number, because when you divide I by 2 and the remainder is 0, so that makes it an even number. Then to display the results, we can use the print function, print, and because I want to make my answer more descriptive, I'll write a word which is a string, so I can use double quotes or single quotes to print this number is even, and then display that number, okay, which is I. Okay, so now else, suppose it's not, the remainder is not 0, else we print the number is odd, and then print that number I. Okay, so let's see how this runs. When you do that, it will say this number is even, and we give us number is 2, because it reaches here, divides the first number by 2 and the remainder is 0, so it knows that is even. Okay, and then the rest is odd. 4 is even, 5 is odd, and so on. So that is how powerful this modulo sign is, or modulo operation is. Okay, now let's try to look at the floor division and what it does basically. Okay, so let's just go straight to let's take a look at modulo the floor division operator, what it does. Okay, so let's take a case. We have 2 given by a double forward slash by 3. What it gives us is 0. Let's have a look at 5 by 3. Okay, we know 5 divided by 3 is around 5 point 1.666. Okay, right? So that will give us 1. Let's also consider let's consider 5 by 2, right? So we know this is 2.5, and that will give us 2, right? One more time, one more trial. Divide by 4. Okay, we know that's 1. Okay, let's look at if this was 5 divided by 3. Okay, what will that give us? It will give us minus 2. So see the difference between this operation and this operation. So in this case, if you have a minus operand, or a minus, one of the quantities is minus, this is rounded to minus, it is rounded off towards the minus infinity. Okay, so that creates a difference between these same numbers, but because this is minus, this is rounded off towards the minus infinity. Okay, let's check the same number. If we have minus 5 over 4, let's see what it gives us. Minus 2. Okay, and yet this is just 5 over 4 is just 1.25, because the other one is a quarter, the remainder is a quarter, 0.25, but then it is rounded off towards the minus infinity. So basically this is basically this is the modulo, and these are the basic operations we have in Python. Okay. So another type is the comparison operators. Let's try to look at how we can compare numbers in Python. Okay, so let's begin by setting a equals 2 and b equals 3. Okay, so we have comparison operators. So let's say a equals, we try to see if a equals b. We know that this a is 2 and b is 3, and we are trying to check if a equals b. Definitely 2 is not equal to 3, so that will give us false. Okay, if a is assigned to b, then that will definitely be one of them. They will be equal numbers. Okay, so let's say if a is less than b, let's see what happens. That's true because a is 2 and b equals 3. Okay, let's check again if a is less or equal to b. Let's see what happens. True. One of them is true because a is less. So let's check if a is greater or equal to b. Okay, let's see what happens. A we know is not greater, so that will give us false because we know a is not greater than b at all. Okay, so basically this is how the comparison operators work.